Hello everyone. In this video, we are going to talk about the Java Stream API. The Stream API in Java, it was introduced in the later version of Java 8. So the Stream API in Java, it provides us the set of functions that can be performed under certain data structures such as array and collection. And by using those functions, we can conveniently to perform bulk operations on those data structures like array and collection, which can help us to avoid iterating the certain data structures elements one by one. Okay, that way we don't have to iterate the elements of data structure one by one and write long lines of code. That way we can just use these stream functions to perform the bulk operations, which makes our codes will to be more shorter and to be more efficient. Okay. And the things that we need to know about the stream is that the stream itself, it is not the data structure. We cannot treat it as a data structure. It is the sequence of elements from the source. From the source can be array or collection. Okay. And every time when the stream instance is created from the source, stream, it takes inputs from that source. For example, if you create it from array or collection, it takes the elements of the array and collection. Okay. And once the stream, it takes the elements from array or collection, the elements within the stream, they cannot be changed. You cannot modify them. They become unchangeable. Okay. So whenever you have any sorts of array or collection, you are able to create the stream instance by calling the stream function from them. And here's how the stream works. Once you create the stream instance from a source is a must-have, first of all, in order to have the stream. Okay. Once the stream instance is created from the source, then we will be able to perform intermediate operations and terminal operations to get the final result at the end. And those intermediate operations and the terminal operations, they are being performed within the stream pipeline. This stream pipeline is the operation that run on the stream to produce the result for us. And within the stream pipeline, we do have intermediate and terminal operations. Okay, depending on the expected result at the end, you will be using the terminal and intermediate operations, the functions that the stream provides, in order to get the result at the end. So therefore, it is essential for you to use the right methods for intermediate operation and the terminal operations. And in Java, we do have those intermediate operations which can be accessed whenever the stream instance is created. Okay, and each of those methods, each of those intermediate operations, they have their own functionality. But all of them at the end, any of those stream intermediate operations that you called, at the end, they will give you stream instance still after the function is performed. Okay, and once the intermediate operation returns you stream instance again, from the stream instance, once you call intermediate operation, you will get the stream instance again. And then from the stream instance, you can still call the terminal operations. Okay, you can still call one of those methods which belongs to the terminal operations. As long as there is a stream instance, then the terminal operations can be accessed. Okay, and once you call those terminal operations, then you will be getting the result at the end. And which terminal operation that you will use, it will be depending on the expected result that you wanted to achieve. And also in our next videos, we will be explaining the functionality of those terminal and intermediate operations. And here is a quick example of why stream is more beneficial. Okay, so using the stream, it is also known as declarative approach to the tasks, which avoids the old imperative approach, which is using the loops and if conditions to a data structure for solving the specific tasks. Okay, and also in the imperative approach, we have to specify every single steps one by one, every single steps and implementations one by one in the old imperative approach. But now, instead of the imperative approach, we can use the stream to have the declarative approach. That way, we do not have to specify every single element step by step, and it looks a lot more shorter and is a lot more easier for us to read as well. Okay. For example, you see, if you had a collection like this that you wanted to remove the duplicates, okay. So in order to remove the duplicates of this collection, you would have, in the imperative approach, you would have to use loop and if conditions to get it to iterate every single element one by one and check the elements one by one in order to get the final result at the end. Okay. So it is taking lots of steps in the imperative approach. But in the declarative approach, if we apply the declarative approach, which is by using the stream, okay, once the stream instance is created, then we can use the intermediate and terminal operations to remove the duplicates and then get all the elements from the stream and return it as the data structure that we wanted. So with the declarative approach, it will be a lot more shorter and it will be a lot more easier for us to read them as well. Okay. So now after the stream is introduced, lots of long lines of hard codes, it can be reduced into one single line. And that is the benefit of the stream. And in order to be able to use this terminal and intermediate operations, first you need to know the functionality of those methods that are in the terminal and intermediate operations. In the next video, we will be going over those functions of the terminal and intermediate operations of the stream. We are going to talk about another intermediate operation of the stream called map. So this map method of the stream, it is used for transforming the elements that are within the stream by applying the specified function. Okay. Anytime if you want to change the elements that are within the stream itself, then you may use the map method to transform the element to the desired element. And keep in mind that any change that are done within the stream itself, they are unable to change the actual stream source. Actual data structure will not, the elements in the actual data structure will not be affected. It only stays within the stream because stream is unable to change the data structure's elements. Okay. For example, suppose that this is the list that is given to you. It contains multiple elements in it. Okay. And if you wish to make change to the elements that are in the list, okay, you may use the map method of the stream. But again, you will not be able to use the stream to change this array list object itself. At the end, you will be getting a new list. Okay, because stream is unable to change the elements of this data structure itself. So therefore, what I can do is here, first of all, I can create the stream instance. Okay, as soon as the stream instance is created, right now in this stream instance, we do have all the elements of this list. And I can make change to the elements that are within the stream instance, not in this array list object, but within the stream instance by using this map method. Okay. And when you call this map method, it is asking for functional interface as the argument. Okay. This functional interface, as we previously have covered, it takes one argument and returns a value. Okay. And the return type needs to be same with the given argument. Since the abstract method of functional interface, it is passing one parameter. When I write the lambda expression to specify this function, I need to pass one parameter as well. For example, I can pass the parameter a. Okay, so now this a, it is representing every single element that we have within the stream instance. And next, you need to complete the function. By using this arrow token, we will be able to give the lambda expression. And lambda expression, it also has the body. Okay. So, for example, if I need to multiply every single element by 10, now this a representing every single element, then I need to make sure that this functional interface, it is returning the element multiplied by 10. Okay. And once you provide this functional interface as the argument, then this map method, what is it going to do is, it is going to multiply every single element by 10. And of course, in the lambda expression, if there is only one statement, this opening and closing parentheses are optional, and you don't have to use the return statement either if there's only one statement that you are returning. Okay, this is the simplest way to write it, this expression right here. So this map method now, it is going to multiply every single element within the stream to 10. Okay, and then in the stream, the elements will be transformed. Once the elements are transformed, if you want to collect them as the new list, because they are not going to make any change to this list that you have, but you will be able to collect them as a new list by using the terminal operation. Okay. Once you collect it as a new list, as soon as it returns your list, then you will be able to assign it back to this list variable. And next, if you print this list variable, in this list variable, you will see that every single element is multiplied by 10. Okay, originally we had 1 to 9, now we have 10 to 90. Okay, of course, if you would like to transform it as some specific elements or certain some elements under the conditions, you may also give it within this within the body of the lambda expression. What if I have multi-lines of code fragments that I need to give within the lambda expression's body? For example, let's say I want to multiply every single odd elements by 10. If the element is even, then I want to multiply it by 3. Okay. So therefore, I'm going to need multiple code fragments in my in the lambda expressions body. So here I can create this if condition if the element is even. This is the condition for if the element is even. If the element is even, then instead of returning that same element, I need to return the element as a multiplied by 3. So what that means is that if the element is even, then we will multiply that element to 3. Otherwise, I can just multiply the element by 10. Of course, we need to use the return statement here as well. Else, return 10. Okay, and of course, you can also give the opening and closing curly braces of the if block. But if there is only one statement that you are giving in the if blocks and else blocks, then the opening and closing curly braces of if block and else blocks are optional. Okay. And if you wish to make it more readable, of course, you can split it into multiple lines. First, let me run it, and then I will show you how you can split them into multiple lines. Now, as you can see, every single elements that are even are being multiplied by 3. And all the odd elements, all the odd numbers, they are multiplied by 10. So 1 was odd number, so it was multiplied by 10. And 2 was even number, and so therefore it multiplied by 3. Okay. And if you have multiple lines of codes that you need to give within this lambda expressions body whenever you use the map method, it is also better if you just split it into multiple lines. Okay. So here's our lambda expression starting body. Within this body here, you can use the format function of the IntelliJ to format it into this line. As you can see, this map method, it is using this function. Whenever a is even number, then it will multiply by 3. If it is odd, then it will multiply by 10. Okay. So by using this map method, we will be able to transform any elements that we want within the string. Okay. And then at the end, you can use the collect method, the terminal operation, to collect the element and return it as the new list. Because the stream itself, it is unable to make any change to this data structure. The only option that we have is to return it as a new one. So this is the map method of the stream. We are going to talk about another stream intermediate operation called filter. So this filter method of the stream, it is used for filtering the elements that are within the stream instance. Okay, it filters the elements that are within stream instance by applying the specified predicate condition. So which means when you call this filter method, you need to provide the predicate condition for filtering the elements that are within the stream instance. For example, suppose that this is the list that is given to you. It contains the elements that are 1 to 9. And what if I just wanted to choose few elements under some conditions and then create my own list at the end? Then we may use the filter function of the stream to filter the elements that we want from the stream. So first step, I need to create this stream instance by calling the stream method from the stream source. Okay. And then once the stream instance is created, then you will be able to use the filter function. Okay. And when you call the filter function, as you can see, it is asking for predicate. So predicate, it is the function, the functional interface. It is the functional interface that represents the functions that returns Boolean at the end. It takes one argument. Argument can be any data type. So in our case right now, we can pass each element of the stream as the argument. So I can use this A to represent, let this A to represent each element of this string. And then I can give the condition for filtering the elements within the string. So I want to filter the elements by if the element under the condition of if the element is, let's say, even. So if I want to filter the even elements only, then next I need to give the condition. So even elements means if the element, which is A in our case, if it is evenly divisible by 2. So once you give the filter condition, this filter method, it is going to choose all the elements that are matching with this condition. Okay, all the elements that can make this condition true, it will be returned by this filter method. So this filter method at the end, it returns you a new stream instance. Okay, and if it returns you a new stream instance which contains the even numbers only, then you can also collect those elements that are within this stream instance by using the collect method. If you wish to collect it as a list, then you can use the collect method to collect it as list. And this collect method returns you list at the end. If it returns you list, you have the option to assign it back to this list variable, or you can also assign it to the new list variable at the end. So if I just assign it back to this list variable, now if I print this numbers, as you can see, now I do have all the even numbers. Okay, so whenever you need to do filterings within the stream within the elements of the stream instance, then you can use the filter function. And this filter function, it is used with the map function a lot more often, right before map function. For example, let's say if you have an additional condition in the operation result at the end. For example, after collected all the even numbers, what if you are asked to transform those even numbers into some different numbers? Okay. For example, instead of 2, 4, 6, 8, let's say I want to multiply each of those elements by 10 in the result. Therefore, what I can do is right after this filter method to filter those elements, those even numbers, I can still call the map function. Because filter, it returns me stream instance. As long as it returns me stream instance, I will be able to use any of the stream methods. And map is also the stream methods. It is the stream intermediate operation. So when I call this map, now I will be able to specify the function for transforming the element. So for example, I can use this A as the element of this element that is within the stream instance. And then if I wish to be able to multiply the elements by 10, here I can give this expression, because functional interface, it returns a value at the end. So this is the value that we are returning. So every time after finish filtering the elements that are even, we are multiplying those elements by 10. And then we are collecting them and return them as a list. So therefore, at the end, in my new list, now I do have 20, 40, 60, and 80. Okay. As long as the functions that you are calling from the stream, if they are returning you stream instance, you will continue to be able to use the other methods of the stream. We are going to talk about the terminal operations of the stream, and we are going to cover the collect method. So the terminal operations, they are the operations that are done right before the operation result that is produced by the stream pipeline. If you look at the flow of the stream pipeline, in the stream pipeline, we have the intermediate operation and then the terminal operation. After those two operations are performed, then it is going to produce the operation result. Okay. So what kind of operation result we will get? It will be totally depending on the terminal operation. Okay. As for this intermediate operation, it will give you stream instance at the end. regardless of what intermediate operation you use, you will get stream instance. And from that stream instance, we will use the terminal operation in order to be able to get the operation result at the end. So the operation result, it's also known as the aggregated result. Okay, it could contain some data like integer or some decimal numbers like double, or it could be also some sort of data structure like array or collection, depending on which terminal operation that you call. Okay. And these are the most common terminal operations that we have. And first one is collect. This collect method, it is used for collecting all the elements within the stream instance and return them as the specified collection type. Okay. If you would like to return the elements of the stream as a specific collection type, then you can use the collect method. Okay. For example, suppose that here is the list of string that is given to you. And there are some conditions for you to filter the elements and return the number of elements from this list. Let's say I want to get all the elements that are starting with J. Okay. So therefore, the easiest way to filter those elements from this list would be by using the stream. So first I can create the stream instance. Okay. As soon as the stream instance is created, then I will be able to call the stream methods. So I can call the intermediate operation and the terminal operations. Okay. I could have jumped to the terminal operation right away, but when I jump to the terminal operation, it will no longer give me stream instance. Then I will not be able to use any stream methods afterwards. Okay. And if you wish to be able to use the stream instance afterwards, it is better if you give one or two intermediate operation depending on the result that you want to achieve. For example, in my final result, I want to be able to filter the elements that are starting with J from this list of string. So once this stream instance, it contains all the elements of this list of string, then I can call the filter function, which is the intermediate operation. And then in the filter function, I will be able to give the predicate condition so that the filter function is going to filter the elements based on that condition that I specify. For example, to give the predicate argument in this filter method, I can give this A as which will be representing each element, and predicate function, it returns Boolean. It must return Boolean at the end. It is passing one parameter. That's why we pass one parameter in the lambda expression. And then we are gonna give the Boolean expression. So this A right now by default is a string. It is a string object because every single element within the stream instance is a string. If it is a string, then I will be able to use the strings methods. So if A starts with J, then those are the elements that I wanted to get. So this filter, it is going to return new stream instance. It is going to give you a new stream. And in this new stream, we do have all the elements that starts with J. And next up, if you want to get the operation result, right now we are still in the pipeline, you see. In order to get the operation result, we have to use the terminal operation. Terminal operation, it is going to give us the operation result at the end. Okay. So depending on how would you like to get all those elements that are filtered here, if I want to be able to get them as a specific type of collection, then I can use the collect method. Okay. And when you use the collect method, it is going to ask you to specify the collection type because we will be using collect method to get the elements as a specific collection type. And good thing is in Java, we also have another class called collector. Okay. And by using the collectors class, by using this collectors class, we will be able to specify how we would like to get that stream object. Okay. So for example, I can use toList method of the collectors class. Then what happens is it's going to return all those elements that are filtered as a list at the end. If it returns me as a list, then I can assign it back to a list variable. For example, I can assign it back to new list variable. To the new list of string. And let's name this variable result. Now if you display this result, this list of string, this list, now it contains all the elements that starts with J from this original list. So that's the functionality of collect method. And again, when you use collect method, you will also be able to specify it. You will also be able to return it as a different type than the list. For example, in the collectors class, we have the methods like toSet, which allows me to return it as a set. Let me change the set, for example. You see, I'm also able to return it as a set. I can return it as any type of collection type that I want. We are going to talk about the reduce method of string. So this reduce method, it is the terminal operation of the string. This reduce method, it is used for combining all the elements of the string and return it as a single value. Regardless of how many elements that you had in a string instance, once you call this reduce method, it will return it as a single value. And as what kind of single value it will be returned, it will be depending on the arguments that you pass into the reduce method. When you call the reduce method, you will pass two arguments. You will be required to pass two arguments. One is going to be the initial identity, and the other one is going to be the binary operator, which is the function, which is the functional interface. So binary operator will decide how the single value can be retrieved from the string after combining it with the initial identity that you specified. Okay. For example, suppose that here I have this integer array. And if I have integers, when I call the reduce method from this string instance that contains integers, it simply gives me the sum of all those integers. Combining the integers means at the end it will return the sum. And if I need to combine them all and return them as a single value, then what I can do is, first of all, I can create the instance of the string by using this array as my source. Okay. And then when you call this reduce method, by the way, since it's not mandatory for you to use the intermediate operations, here you don't have to give any intermediate operations at all. Once you call this reduce method, you need to provide the initial identity and binary operator. Okay. So if you don't want any other number to be added on top of those numbers, for example, initial identity, I can set it to 0. And next, I need to pass the binary operator, which is a functional interface, which means I need to give its lambda expression. So this binary operator, this functional interface, it is for the function that passes two parameters and returns the value. So therefore, in my lambda expression, I am going to pass two parameters here, for example, A and B. And then I need to give this arrow token, and where I will be able to give the body of the lambda expression. Okay. And if I just want to be able to find the sum of them, then I can just give A and B. So here, what is this A is that A is basically the initial identity that you pass here. And B, it will be representing each element of this array. So each element of this array will be added into this initial identity that you specified, which is to 0. Okay. So first it is going to be 1 that will be added to the 0, and then it's going to be 2, then 3, 4, 5. At the end, it is going to return you the single value. Okay. So depending on the stream instance that you call this reduce method's return type is going to change. If you are calling this reduce function from the stream instance that contains integer elements, then this reduce method, it is going to return you integer at the end. Okay. For example, I can assign it to the variable sum. And if I print the sum now, sum, it simply is the sum of those numbers from 1 to 5. Okay, so 1 to 5, they are being added to this initial identity that I specified. And imagine if I did not specify this initial identity as 0. What if I give 1? Then what happens is those elements will be added to this initial identity 1. So at the end now you will get 60. Okay. But if you just want to get the sum of all those combination of all those numbers that are in this stream instance, then it is better if you give 0 as the initial identity. And of course, you can also combine other elements that are in the stream instance. It doesn't necessarily has to be integer. If you have string elements in the stream instance, you will still be able to combine all the strings from a stream instance. For example, here, suppose that this is the string array that is given to you. And if you call the reduce function from the stream instances of this array, then it will return you a single value, a single string value. Let's create the stream instance from this array. Okay. And when I call this reduce method, I need to specify the initial identity. So if I don't want anything else to be included when I am combining those elements, then for the initial identity, I can just give empty string if it's needed. Okay. And then I need to give the binary operators expression. I need to give the lambda expression for this binary operator functional interface. So since this functional interface abstract method is passing 2 parameters, when I write its lambda expression, I need to pass 2 parameters as well. For example, x and y. Okay. And at the end, it needs to return a value. So for example, if I just wanted to combine them, I can give this expression. And now this reduce method here, since you are calling this reduce method from the stream instance that contains the string elements, then the return type of this reduce method right now is string, which means I will be able to assign it to this string variable. And if I display the string now, it contains all the elements of this array, as you can see here. And of course, how you give the lambda expressions body is that's also how you are going to get the combination of those elements. For example, if you wish to have some space, extra spaces, then you can also include the extra space before you concatenate each of the element of array. Here, in my case, the second argument, it contains each element of the array, and this x is the initial identity that I specified here. And now if I run it, as you can see, I do have a space that is included in every single value here. Okay. So this is the reduce method. Remember that every time when you call the reduce method, it will just return you a single value from that string. It simply combines all the values that we have within that string.